There are places in the universe where space itself breaks down, where gravity becomes so intense that not even light can escape, where the laws of physics as we know them reach their absolute limit, and something else, something we do not yet understand, must take over. These places are black holes, and among the billions scattered across the cosmos, from stellar remnants to galaxy-devouring giants, one stands above all others. TON 618, 66 billion times the mass of our Sun. An event horizon larger than our solar system, the largest confirmed black hole ever discovered. This is its story. This is the story of how black holes are born, how they grow, and how they come to devour entire galaxies. Buckle in. We're going inside. Every black hole begins with a star, not just any star, but a giant. A star so massive that our Sun, by comparison, is a candle flame beside a supernova. These stellar behemoths burn through their nuclear fuel in the cosmic equivalent of a few seconds. Millions of years that barely register against the age of the universe. And when the fuel runs out, the consequences are catastrophic. Not for the star's neighbors, for space itself. The core collapses. In a fraction of a second, a sphere larger than Earth compresses to the size of a city, and in that moment, a new black hole is born.
At the center, the inert iron core expands.
Consider what an event horizon truly means. It is not a physical surface. You cannot touch it. There is no wall, no barrier, no signpost reading point of no return. If you were falling toward a black hole, you would cross the event horizon without feeling anything special. The universe around you would still look recognizable for a moment. But from that instant forward, every possible future, every direction you could move, every path available to you through space-time leads only inward, toward the singularity. There is no going back, not because of speed or strength, because the geometry of space-time itself offers no path outward. Einstein told us this was possible. It took us a century to prove him right. In 2019, something unprecedented happened. 200 scientists across 20 countries combined data from 8 radio telescopes on 5 continents, creating effectively a telescope the size of the Earth itself. The target, the supermassive black hole at the center of galaxy M87, 55 million light-years away, 6.5 billion times the mass of our Sun. The result, the first photograph of a black hole. That glowing orange ring, asymmetric, real, precisely as general relativity predicted, was one of the greatest scientific achievements in human history. Einstein, working with pen and paper a century earlier, had described the geometry of this ring perfectly. He never saw it, but he was right.
At the event horizon, quantum fluctuations create virtual particle pairs. One escape.
Capitulo 3. The black hole is born.
There is a black hole at the center of our galaxy. Right now, as you watch this, 26,000 light-years away, Sagittarius A sits at the heart of the Milky Way, 4 million solar masses of compressed space-time, surrounded by a dense cluster of ancient stars in tight, fast orbits. We have seen it. In 2022, the Event Horizon Telescope turned toward the center of our own galaxy and captured its image. Our local black hole, our cosmic neighbor, rendered visible for the first time. It is surprisingly quiet now, but the Fermi bubbles, vast lobes of gamma-ray emission stretching 25,000 light-years above and below our galaxy's disk, are the scars of a much more violent past. Sagittarius A was not always sleeping.
The merger is complete. As the gravitational waves ring down.
Quasar, the most luminous sustained objects in the universe. Active galactic nuclei powered by supermassive black holes accreting at maximum rate.
How does a stellar mass black hole become a supermassive one? This is one of the deepest unsolved problems in astrophysics. We observe quasars, black holes accreting at full fury in the universe's first billion years. Yet those black holes already contain billions of solar masses. There wasn't enough time for them to grow from stellar remnants through normal accretion. The math doesn't work. Astronomers have proposed solutions: direct collapse of massive gas clouds, rapid mergers of black hole seeds in the early universe, super Eddington accretion at rates our physics struggles to explain. But the answer remains incomplete. Somewhere in the early universe, black holes found a way to grow impossibly fast. TON 618 is the most extreme evidence we have.
Gravitational lensing by this massive galaxy cluster acts as a cosmic telescope, bending.
Black holes are not destroyers, they are architects. The supermassive black hole at the center of every large galaxy is not merely a gravitational drain at the galaxy's heart. It is a co-creator. Its jets heat the surrounding gas, preventing runaway star formation. Its winds regulate the galaxy's growth. The mass of the black hole correlates precisely with the properties of the surrounding galaxy, a relationship that transcends scale, spanning from the smallest ellipticals to the most massive galaxy clusters. The galaxy and its black hole grew together, shaped each other. The black hole is not the galaxy's prisoner, it is the galaxy's architect.
66 billion solar masses. This is TON 618.
In September 2015, at 5:51 in the morning Eastern Time, a ripple in space-time passed through the LIGO detector in Livingston, Louisiana. The detector moved by a distance 1,000th the width of a proton. That signal, a chirp lasting less than a second, was the merger of two black holes 1.3 billion light-years away. Two objects of 36 and 29 solar masses spiraling together at roughly half the speed of light, releasing more energy in that fraction of a second than all the stars in the observable universe combined. Humanity had opened a new sense. We could now hear the universe, not in light, but in gravity itself. The gravitational wave era had begun. The information paradox is perhaps the deepest crisis in modern physics. When something falls into a black hole, what happens to the information that describes it? Quantum mechanics says information cannot be destroyed. It is one of the most fundamental laws of nature. General relativity says the event horizon is a one-way door. Nothing that enters can leave. Both cannot be right. Yet both are our most tested, most accurate theories of reality. Stephen Hawking spent decades on this problem, changing his position 3 times. The greatest minds in physics, Hawking, Penrose, Maldacena, Susskind, Polchinski, have devoted careers to this question. It remains unsolved. At the boundary of the event horizon, 2 pillars of physics stand in fundamental contradiction. The resolution, when it comes, will likely be the greatest revolution in physics since Einstein. Somewhere in the universe right now, in a galaxy so distant, we may never observe it, 2 supermassive black holes are spiraling toward each other in a gravitational embrace that has lasted millions of years. Their merger will release more energy in gravitational waves than anything else in the observable universe. The ripple in space-time will travel outward at the speed of light, washing over everything in its path, including, eventually, whatever detectors civilization has built by the time it arrives. We are building those detectors now. LISA, the Laser Interferometer Space Antenna, will launch in the 2030s, 3 spacecraft separated by 2.5 million kilometers, listening for exactly this signal. The universe has been sending these messages for billions of years. We are finally building the ears to hear them. In 1067 years, a number so large it makes the current age of the universe look like the first picosecond of a billion-year story, the last stellar mass black holes will evaporate. Their hawking radiation, barely detectable today, will have slowly stolen their mass back from them, atom by atom, photon by photon. In 100 years, the supermassive ones will follow, and then there will be nothing. No structures, no gradients, no useful energy. The universe at maximum entropy, thermodynamic death, heat death, the final state that physics predicts for everything. Not a bang, not a crunch, a whisper fading slowly into silence over timescales that make our deepest human concepts of eternity seem like an eye blink.
The supermassive black hole sculpts the very structure of the galaxy, a gravitational symphony conducting the fate of the stars.
The galaxy jet interacts violently with the interstellar medium. The jet carves through the disk, creating these massive
We are made of star stuff. Carl Sagan said it beautifully, and it is literally true. The carbon in your DNA, the oxygen in your lungs, the calcium in your bones, all forged in stellar cores over billions of years. But there is more. The iron in your blood, every molecule of hemoglobin, every red blood cell carrying oxygen through your body right now. That iron was made in the final seconds of a massive star's life, in the moments before the core collapsed, in the instant before a black hole was born. We carry in our own blood the last breath of dying stars. We are, in the most literal sense, made partly from the debris of failed black holes. Stars that tried to hold themselves together and couldn't. The universe is inside us, and we are inside the universe. Every photon of light that reaches your eyes has escaped something. Every image of a distant galaxy represents light that traveled billions of years without hitting anything, without being absorbed, without being trapped. Light is rare. Light is fugitive. Light survives. Inside a black hole, no photon escapes. The event horizon is the boundary between the universe of light and the universe of permanent darkness. Every photon that crosses that boundary is a photon the universe will never see again. TON 618's event horizon has swallowed the light from billions of stars, from billions of years of stellar history. That light is gone forever, not destroyed perhaps, but permanently removed from the observable universe. What does a black hole look like from inside? We will never know. The universe will never tell us. That is the most profound silence in existence. The largest black hole ever discovered, TON 618, is not a destroyer. It is a monument to 14 billion years of cosmic evolution, to the birth and death of countless generations of stars, to galaxy mergers, cosmic web formation, and the patient accumulation of mass across timescales our minds cannot truly hold. It took the universe almost its entire history to build this object, and it will take the universe, at its current age multiplied by 10^86, to dismantle it. Inside TON 618 eyes, a singularity where our physics breaks down and something new must begin. Outside TON 618 is a universe it helped create. Between those two things, the singularity and the cosmos, is the event horizon, the largest event horizon ever measured, the final boundary of the known. What lies beyond it is the universe's deepest secret. Before we witness the final frame of this journey, if you've traveled these 20 minutes with us through stellar death and galactic cannibalism, through the birth of the universe's largest known black hole, and into the long darkness of cosmic time, you're part of something rare. Hit subscribe to keep exploring the cosmos with us. Leave a like if this journey left you in awe, and drop a comment below. If you could send one message into a black hole, knowing it would never return, what would you say? Now, let's witness the last image. In the end, we return to what we began with. Darkness. Not the darkness of ignorance, but the darkness of the event horizon. A boundary we can describe mathematically with perfect precision, and yet cannot cross. The largest black hole we have ever found sits 4 billion light-years away, in a universe that may be infinite, containing structures we have not yet imagined, and black holes we have not yet discovered. We are a civilization that has, in the span of a single century, gone from not knowing black holes existed to photographing them, hearing them merge, and mapping their influence across the observable universe. The universe is 13.8 billion years old. We have been asking these questions for perhaps 10,000 years. We have had the tools to begin answering them for barely 100. We are very young. The black holes are very old, and the conversation between us, between the brief, curious, light-emitting creatures and the ancient, permanent, light-consuming giants, has only just begun. Look up. The largest thing we have ever discovered is out there, in the dark, waiting.